6.2 on similar polygons. We started to get into our talk about similarity with polygons, and we'll focus a lot with triangles as we go through. So here we go. Similar polygons. They're polygons where the corresponding angles are congruent and the corresponding sides are proportional, meaning if I match up the sides that correspond with each other, each of those ratios should work out to be the exact same thing. For example, I've got two triangles here, triangle ABC and triangle DEF. You'll see we've got all three side measurements for triangle ABC, as well as all three measurements for triangle DEF. We've also got some congruence markings in terms of the angles. Angle A, we can see is congruent with angle D. Angle B is congruent to angle E. And we can see that angle C is congruent to angle F because they're both right angles. So that kind of takes care of the first part of our definition. Corresponding angles are congruent. So that's true. The corresponding sides have to be proportional. So here we can see that side AC corresponds with side DF. So we set up a ratio of 6 to 3, which will reduce down to 2 over 1. If you look at the hypotenuse of a big triangle and the hypotenuse of a smaller triangle and set that ratio up, 10 over 5. Again, that reduces down to 2 over 1. And then finally, the base CB compared to the base of this one, FE, 8 over 4. Again, we get that ratio of 2 to 1. So all three pairs of sides reduce down to a ratio of 2 to 1. That means that the corresponding sides are proportional. So since corresponding angles are congruent, corresponding sides are proportional, that means that triangle ABC is similar, this little squiggly line right here, that means is similar to triangle DEF. Alright? And this is what we call a similarity statement. We'll get more into that here as we get into another example. We'll talk a lot about that tomorrow as well. So that's our definition of similarity in terms of polygons, and there are examples showing how that definition works. The ratio of the corresponding sides that we just came out with, that 2 to 1, is what we call a scale factor. And the scale factor is a common ratio of the corresponding sides. So again, depending on how you compare the two polygons, whether they're quadrilaterals or triangles, pentagons, hexagons, doesn't matter. But how you compare them, if you go big to small or small to big, will kind of determine on how that scale factor is set up. We've got an example here involving two quadrilaterals that look like parallelograms here. We've got quadrilateral EFGH, quadrilateral JKLM. We can see we've got some side measurements here, as well as a measure of angle L. Now I'm telling you that the two quadrilaterals are similar. Quadrilateral EFGH is similar to quadrilateral JKLM. Since we know they're similar, we know that certain things are going to be true. We know that the corresponding angles are going to be congruent. So angle L, we can see matches up with angle G because they're in the same spot within our statement. So if that's the case, then we know that if angle L is 100 degrees, that angle G also has to be 100 degrees. So right here where it says what's the measure of angle G, we know that's 100 degrees. What's the length of segment GH? Whoops. I meant to put EH. That's a little bit of a boo-boo on my part. That's okay, we fix it. So segment EH right here, unknown length. The good thing is, though, we know that its corresponding side in the smaller quadrilateral is 6. So I can compare those two sides to each other. So I know that I've got x compared to 6. Well, I've also got 12 for EF and 8 for JK. Those two segments correspond with each other based on our statement. So I know that I've got 12 compared to 8. You've got a proportion set up, we can solve the proportion. Cross multiply and divide. 8x equals 72. X equals 9. So we know that EH has a length of 9 units. The perimeter of quadrilateral EFGH, again, if we know they're this side also has to be 9. So in terms of perimeter, add up all your sides, 12, 24, and 18. We know the perimeter is 42 units. Questions so far? Oh, that's right, you can't ask. Because you're at home watching this on the computer. All right, we'll talk about it tomorrow. Lastly, we've got 2 last examples here. You can see we've got some pentagons. The 2 polygons are similar. We want to write a similarity statement, which is what we had in the very first slide with the triangles. We want to find the values of x, y, and the length of segment UT. All right. So again, if you want, pause the video, get all your stuff written down. Ignore that part right there because that's one of the answers. You'll be all set. And we're back. So similarity statement. I'm going to compare the bigger pentagon to the smaller pentagon. So pentagon RST UV is going to be similar to, and we see we've got a little symbol for similarity here. Pentagon. Just match up the corresponding angles. A, B, C, D, E. And I know that those angles match up with each other because of the congruence markings with each pair. So that's our similarity statement. In terms of finding the value of x, here we've got x for segment RV. That matches up with segment AE. So I can write a proportion that starts out with x over 3. Right here I know that ST has a length of 18. BC has a length of 4. So again, I've got a pair of corresponding sides where I know both lengths. That's good, because I'm going to use that as the other part of my proportion. Notice that x and 18 are on top from this pentagon. 3 and 4 on the bottom, they're from the smaller pentagon. So it's nice that we keep those measurements in the same spots because they're from the same pentagons. Cross multiply, we got 4x equals, what's that, 54. If we divide, that's going to be 1 and 13 and a half. That's good. So we can use the same ratio, 18 over 4, to help us figure out the value for y. 18 is on top, so y plus 2 will also be on top. Y plus 2 matches up with segment CD. That's 5. So again, we're going to cross multiply. Make sure you use your distributive property here. So we got 4y plus 8 equals 18 times 5. We'll call that 90. So 4y equals 82, which means that y is 20.5. So now that I know the value of y, I know that segment UT is 22 and a half units long. Just take your answer and substitute in. So, one last example to take a look at. Here in the last example, we're going to match the ratios on the left with these similar ratios on the right. So again, if you want to write it all down and see what you can come up with, now would be a good time to pause the video and write those down. Alright, so hopefully we'll check and see if you're able to match these up correctly. 3, 3, 4 is going to match up correctly with 6, 6, 8. You're just doubling it up. 6, 8, 10 is going to match up with 3, 4, 5. Just cut it in half. 4, 6, 8. If we cut that in half, we come out with 2, 3, 4. And in D, you've got 4, 4, 4. Well, that one's got to match up with one that's all the same as well. And so that matches up with 5, 5, 5. So, those are the notes on similar polygons. We'll come in tomorrow and take a look and see what you've got done. And probably take a look at some stuff on a worksheet book and get you guys going. If you have any questions, let me know tomorrow when you come into class.